Hi there. So this is a tricky question. It's actually a related rates question. It says a point moves along a curve, and they gave us the curve. This is this parabola here, so that the x coordinate increases at a constant rate of 1.5 units per second, right? Question is find the rate at which the distance from the origin is changing, okay? And so they're wanting us to find the distance from the origin here. The distance from the origin is, I'm going to label it as a D, okay? And they give us the coordinates 1, 2, all right? Now, they ask us in several different, instead of just leaving the question like that, they actually kind of ask several different sub questions to kind of, in a way, I think, sort of help you work through this question. But I find that it's actually maybe a little bit more confusing that way. So, whatever the case, it says what equation can be used to relate the x and the y coordinates to the distance. So that's just your standard distance formula. So the distance from the origin is x squared plus y squared, okay? Then it says, since we only know the rate of change of the x coordinate, what expression can be substituted for y? So here they kind of want you to notice that they gave us the function y equals x squared plus 1, which means that all the y coordinates on this function can be figured out by using x squared plus 1. And so you would, instead of using y, you just use x squared plus 1. Then it says, take the derivative of the equation in part B. Okay, and so here's our part B, and I'm going to implicitly differentiate this. And so I'm going to move my 2 down, and I'll leave the d, and then I'll take the derivative of d with respect to time. So it's d dt. And then same thing here. I'm going to move the 2 down and get it to there. Leave my x, and the derivative with respect to x is dx dt. Plus, here, I'm going to differentiate this section of the function here. So this 2 moves to here, and I replace my x squared plus 1, okay? And I lower my 2 to a 1. And now I take the derivative of this. So it's here, the derivative of this is just another 2x times dx dt, okay? Now this is the rate of change of x, okay? So this is the rate of change of x with respect to time. They want to know the rate of change of the distance with respect to time, okay? And so here it is. I would have to just isolate for this. So I divide by the 2 and the d. I think I forgot to write my 2 here. My 2 goes right there. And my d, remember, it's a changing value, but they want to know at the moment of 1 comma 2, or the point 1 comma 2. So you can actually figure out this d value using the Pythagorean theorem. So it's just the root of 5, okay? So this d gets moved down to the bottom, so we get a root of 5. This 2 gets moved down to the bottom through division. And now all of these things up in here, we know. So this is a 2, so we write it. X is the x coordinate. We know that that's a 1, okay? This is the rate of change of x, or 1.5. So this is going to be another 1 over here. This is going to be another 1 over here. And then this is going to be another 1.5. And when you simplify all this stuff down, apparently you end up getting a 3 root 5 over 2. Okay? Anyway, so that was a very tricky question because of the way that they kind of asked everything. But that's how that one works.